Okay, in our next lesson, we're going to talk about what we're doing with these quadratic equations and what's the point of factoring them. So if you remember, let's say we had this quadratic, which is v squared minus v, why did I write a 4? V squared minus v minus 12. Is it a quadratic? Yes, it is. So when we solve quadratics by factoring, first we have to factor them. So let me take that exact one and write it on the next page, because also in this lesson we're going to add an equals 0. So now we've turned a quadratic expression, which we've just been practicing simplifying, into an equation which has an equal sign and a solution. So equations have solutions and equal signs. Well, this equation looks a lot like what we've been dealing with. It's a quadratic. The important part is it equals 0. Now, let me do a little side note real fast. If you had 3 times x and you knew that equaled 0, what does x have to be? X has to be 0, because any two things, when they are multiplied together, if one of them is 0, your whole product is 0. Alright, well, what if you had y times 2 equals 0? Well, then you know that y has to be 0, right? Okay, well, what if you have y times x equals 0? You should know by now that you have two possibilities. Either y equals 0 or x equals 0. You may not know which one is 0, but you know one of them has to be 0. They could both be 0 for all we know. But definitely either this one or this one is 0. Otherwise, you cannot get a product when you multiply them of 0. Okay, let's keep that knowledge in the back of our mind as we work with these quadratic equations. So first thing we got to do is factor. Well, let's use the old parenthesis method. So factors of 12, 1 times 12, 2 times 6, and 3 times 4. Now where am I trying to get to? That's a 1. Come back over here. Obviously, the 3 and the 4 are my winners. Now, since I have a negative product in the negative 12, that tells me one of them's positive and one of them's negative. When I add them up, I need to get a negative 1. So that tells me the 4 is my negative. So that's v minus 4, v plus 3. Remember how to double check if you don't know if you factored it correctly. Multiply that back out and make sure that you get exactly what you started with. Okay, so now you should be looking at this and you should notice that it's one piece times another piece equals 0. What did we just talk about? One piece times another piece equals 0. So either the first piece is 0 or the second piece is 0. That's the only way to multiply them together to get 0. So either v minus 4 equals 0 or v plus 3 equals 0. Well, now you got two little equations that you learned how to solve on the second day of class, maybe the third. So you'll add 4 to both sides. cancel that, so v equals 4. Or, that second equation, let's subtract 3 from both sides. V equals -3. So you have two possibilities because you had a quadratic equation with an lead term of a second degree. You have two possibilities for answers. So either v equals -3 or 4. Now do not be confused. That is not an XY point. These brackets are not parentheses. This is set notation. So basically it says your solution is a member of this set of numbers. And the way we represent a set is with these funny looking brackets. So if you go and look at question 1, you'll see D is the correct answer. Now, that was already factored for you, but I wanted you to see how they got to that and where you might be starting. So let's look at number 8, because 8's a little more complex. So it's already factored. 4x minus 5 times 3x plus 5 equals 0. So either the first piece is 0, or the second piece is 0. Now you solve those two equations and you will get your two solutions, or your set of solutions. And you're going to solve these using all the things you have already learned how to do that you're very good at by now. And it's okay to have fractions. Leave them in fraction form. Just make sure they're simplified. So we have a set now of solutions. Typically in a set you will write the answer from smallest to greatest, but it's really not that big of a deal. Just make sure that you know your answers may be written backward to the choices and just be able to find them. Okay, and so if you look at your answer choices on number 8, you can see the answer is D. Now let's look through this worksheet, because when you get on further in, they get a little more difficult as usual, right? So let's look at number 12 to start off. We have a problem on 12. Because remember on the first slide, these equations, before you can solve them, have to be equal to 0. You have to get every term on one side of the equal sign to leave a 0 on the right. Sometimes this is challenging to do because we just get confused when we leave something on when we leave one side empty, because we're so used to getting a variable on one side and a number on the other. Just takes practice. So we're going to subtract n from both sides, and don't you dare say that n squared minus n is n, because n squared minus n is simply n squared minus n. Those are not like terms. They do not combine. That's a hard part about these quadratics, because we always want to combine those terms even though they don't match. Now, n squared minus n, before we can figure out what these pieces are, it has to be completely factored. And in the first few problems that you had on this assignment, they were factored. Well, now they're not. So we have to factor this. You can use AC method if you want. You can use the parentheses if you want. What you need to know is you're factoring that. Because remember, to use either one of those methods, you have to have this written in standard form, which is ax squared plus bx plus c. So you're going to have to put a placeholder in there to keep that straight. Or, if you go back to the baby method of factoring, there's a common factor there of an n. So let's take out that n, and when we take out, what we mean is divide both pieces by the n. Now, do we have one piece times another piece? And yes, we do. So the first piece is just the n. So either n equals 0, helpful, that's already solved for you, or n minus 1 equals 0, and that one's easy to solve. Add 1 to both sides, n equals 1. Your solution set is 0 or 1. Those brackets are hard to make sometimes. So if you look at your answer choices, B is the answer. Now as I scan this assignment, I notice many of these are not already equal to 0. So your first challenge is to get that done. Let's look at number 24. So 24 says negative 16 minus 7n equals negative 21n squared plus 3n. We need every single thing on one side of this equation. Myself, I don't like a negative lead term, so I'm going to add 21n squared to both sides. It's going to leave me with 21n squared minus 16 minus 7n equals 3n. So I'm going to subtract 3n from both sides. 21n squared. Now I already know that the n's need to come next because I need this in standard form. So I'm just going to go ahead and move them over. Now the next thing you do is you look for a common factor. Remember, if you can shrink these coefficients, this factor job is so much easier. So I know 7 times 3 is 21, but there's no 3 in 10. There's no 3 in 16. There's no 2 in 21. There's no 5 in 21. No 4s. That is bad news for us because that means that's already factored. So on these big numbers, I always think it's easier to use AC method because your parentheses are going to be n and 21n, and you're going to have to check that pair with every possible factor of 16. There's a lot. 2 and 8, 4 and 4, 1 and 16. Also, you have 3 and 7 in that could possibly be your first two terms. And again, you have 3 possible factors of 16, and you have to try them both ways. So that's a lot of experiments of multiplication. So even though A times C is going to be big, let's try to do it. So 21 times 16 is our A times C, and that is 336. Now, remember, we're trying to rewrite this middle term into 2 pieces, which are factors of 336. So we have 1 times 336, that obviously ain't going to do it. We are never going to get to a 10 with 1 and 336. So probably 2 is not going to work either, because those factors are too far apart. So let's say 336 divided by 12. Well, 12 times 28 was just a lucky guess, y'all. I did not know that. 12 times 28 is 336, but now let's look at it. With 12 and 28, we could get to 16 or 40. It's still not going to get us to a negative 10. So this has to get bigger, and this has to get smaller. All right, so now what I'm going to do is I'm going to say 336 divided by 27. That is a decimal, so that's not going to work. So I'll say 336 divided by 26. That's a decimal. It doesn't work. I already know 25 is not going to go into 336. So let's take 24. 336 divided by 24. That is 14. So 14 times 24 is 336. Now, let's backtrack a minute. I know that 2 goes into 336, but that's 2 times 168. That is not going to give me a 10. So I knew ahead of time that these numbers had to be pretty close to one another, within 10 from one another. And so that's why I immediately skipped to a bigger number. I knew 10 did not go into here because it didn't end in a 0. I knew 15 did not go into here because it didn't end in a 0. I just arbitrarily chose 12 and got lucky. When I got to 12 and 28, the difference between them is 16. I'm trying to get to 10. They're still not close enough together. Now, you could have done 336 divided by 13 and then divided by 14. I went the opposite way. I was going to shrink this second factor. Either way will get you there. 14 and 24 definitely have a difference of 10. Now, we need to get to a negative 10. Rewrite the second term. So you're going to have a positive 14n and a negative 24n to get there. Now, take your grouping method, put the first two together, put the second two together. Now, you see that negative? I don't know if we need it in or out. I have no clue right now. So I'm going to try with it out and see if I get to the right place. All right, so over here I know a 7n is my common factor. If you cannot see the common factor, remember how we did it on the first lesson. We took 21n squared and we expanded it. That's 3 times 7 times n times n. And then we took 14n and we expanded it. 2 times 7 times n. And then we said, okay, what's the greatest common factor? Well, there's a 7 and an n. And so that's your common factor that you're going to take out. Because sometimes these will be big numbers with big common factors and they're hard to see. Alrighty, back to the wrench. So 21n squared divided by 7n is going to give me 3n. 14n divided by 7n is 2. This goes back to rules of exponents, something we learned way back in chapter 1. I'm just going to leave this minus sign here for now because I have no idea what's going to happen. But I do know I need a positive 2 inside here in this piece. If this is going to work, these two pieces are always the same. Hopefully you've seen that pattern. These two pieces are identical. So I know if this is going to work, I need a plus 2 right there. Well, to get a plus 2 right there, that would mean I would take out a negative 8, wouldn't it? Okay, so if I take a negative 8 out, the first term is going to be a negative 3n. Is that what I wanted? No, I want a positive 3n. That tells me that that negative sign on that 24 needed to be inside my group. The only way is to look at it. Now, I have a plus here and then 3n plus 2 and a negative 8 is what came out. Well, plus negative 8 is just negative 8. That's the difficulty with the AC method, is when you need a negative factor to come out because it's hard to keep in your brain straight. Now, when you factor this common binomial out, it's 3n plus 2 times 7n minus 8. all of that was equal to 0. We did all of that just to factor it. We're still not done. We're trying to find the solutions. So either the first piece equals 0 or the second piece equals 0. So either 3n plus 2 or 7n minus 8 equals 0. Because the whole equation, we got it equal to 0 when we moved everything to the left. The reason we get it equal to 0 is so that we can solve it. Because we know a quadratic equation is going to have two solutions, and we're going to factor it at the end. The only way to solve a quadratic equation is to get it equal to 0. Now let's solve these just like we have been doing forever, it seems. So we'll subtract 2, so 3n equals negative 2. Then we'll divide by 3. N equals negative 2/3. Or, let's look at the second factor. 7 minus 8 should equal 0. So add 8 to both sides. 7n equals 8. Divide by 7. And n equals 8/7. So you have two solutions, negative 2/3 or 8/7. And if you go back and you look at your choices, that's B. So one thing to remember with these fractions, make sure they're simplified. For instance, if you came up with a solution that said either n equaled 4/12 or negative 2, this is just a made-up example. Okay, this is none of your answers. I just made this up. 4/12 is not going to be in your bracket. 1/3, however, will be, because you have to always simplify your fractions. So if you come to the end of a problem and you don't see your answer there, check the fraction, make sure it's simplified before you go back and redo all of that factoring. Just double check that. Okay, good luck.